what we have to do is to identify resistance genes, to map them, resistant gene or quantitative trait loci that we can use, and to develop the final goal is to develop PCR primers which can be used to do master assisted selection. So with master assisted selection, we will not take so long time to have cultivars, resistant cultivars of sorghum, which will help to increase yield. You can have a cultivar which has a high yield, but if you have a disease like grain mold, you don't have a good quality of grain. We'll try to find genes associated with diseases of sorghum and identify markers or SNPs which can be used to to improve the process of getting good cultivars with high yield.
It would be really, really good if these guys in Africa, if they could be able to do their own gene tagging and track for next generations based on a simple PCR reaction. And so I actually had one guy spend about a year here, and we sent him back with all the equipment that he could need to do these simple experiments. And come to find out, they didn't have reliable electricity, they didn't have reliable refrigeration, and it was going to cost a fortune. So later on, in this particular case, that was with sorghum, of course. They wanted the diversity of fungi to see how they compared. They were doing breeding in India for resistance. I ended up having several students working in my lab and so forth with joint projects. And after he left, I tried to get one of my own on the same idea, is that it would be really, really good if these guys in Africa, who the ones I met have been very bright and capable of anything, but didn't have the equipment or the tools and needed a little experience doing this.
And the focus is actually to look for resistant sources to multiple sorghum germplasm, diverse germplasm, because the genetic base is really narrow. So what I'm trying to do is actually look for sources that have multiple disease resistance. As I said, it's primarily working on identifying resistant source against anthracnose, against head smut, downy mildew, and grain mold. I wanted to know what's actually going on in other countries. And this was an opportunity for me to go to Senegal and Niger and conduct a survey and see whether the diseases that I'm working here in the US are also prevalent in those two countries. So this was really important to me, because looking at the literature, especially for those two countries, I found out that no extensive survey of sorghum diseases in those countries have ever been done. So this was an opportunity for me to actually go out there and look at what diseases exist of sorghum exist in those two countries. I think it's developing inoculation techniques that everybody can use. Developing a disease scale like anthracnose, explaining why the scale is important. For instance, in our anthracnose scale, we are looking at the presence of Acervoli, the fruiting body for anthracnose. Because if the pathogen survives on the leaves and produce those Acervoli, they are able to splash it to other leaves. But in the other type of reaction to anthracnose is the hypersensitive reaction. So I won't concentrate on that. Our scale gives you two types of classes, either resistant or susceptible. And to map any gene, if you use our scale, it will be easier to map the gene for anthracnose resistant than using other scale where the pathogen doesn't reproduce in the host, but just causes the foliar infection or hypersensitive infection reaction to rain. So I'm very proud of that.
Since we started the project with the COVID-19, we didn't have no time to do the things we wanted to do. So, therefore, for the pathogen we isolate on anthracnose, we still didn't do the DNA extraction. We still didn't do the pathogen genetic diversity. and which is a problem. Actually, I get the material for the DNA extraction, but I don't have material for amplification. So I have to go to Sahara to do amplification and come back and do the precipitation and send them to Maggie. And this work, we should do this since the second year. So now we are late, and I am so worried about that because I don't know if we will have time to finish it before the end of the project because we are in the last year. So that's what I want to be if I can have new material for electrophoresis, gel, and for amplification, PCR, thermocycle, it will be very, very grateful. So here in the plant pathology lab, we have many SMIL materials. This one, it is for SMIL by, we bought this one by SMIL on the SMIL project. So before this, we have one fridge in the other side, but it was a small one. So with the project, we buy this one.